Wooden block of mass 100 kg rests on a flat wooden floor. So let's say this is flat wooden floor, and on this there is a wooden block of mass 100 kg, and the coefficient of friction between the two being the coefficient of friction between the two is 0.4. Now this block has to be pulled by a rope making an angle of 3 degree with the horizontal. So let's say this is the angle with the horizontal. This is the horizontal, and this is the rope that is being pulling the block. So this is 30 degree. And this is now for the two rectangular components of this tension P. These are the two rectangular components. This is the horizontal one, 2, 3, cos 30 degree, and this is P sine 30 degree, and this is also the normal. The weight is acting vertically downwards. This is mg. This is the force of friction in this direction because the block is being pulled in this direction. So let's try to, so these two components, P sine theta, P sine 30 degree plus normal direction R is being balanced by the weight mg. This is equal to mg. Now, and normal direction n is equal to mg minus T sine 30 degree, and sine 30 degree is half, so normal direction n is equal to mg minus T by 2. Okay, so this is the normal reaction. Now, to find the minimum tension along the rope that just makes the rope sliding or the rock sliding, this T cos 30 degrees should be greater than or equal to the force of kinetic friction. So T cos 30 degrees should be greater than equal to the maximum force of the friction. And we know that the force of the friction is given by nu into R, the normal reaction. And we have got the value of normal reaction. The normal reaction is mg minus T, mg minus T by 2. Okay, so let's find out T. Okay, so let's move these terms with T to one side. This is cos 30 degree plus nu T by 2 is greater than equal to nu m into g. Cos 30, so let's take T common. So this is cos 30 degree into nu by 2 is greater than equal to nu into mg. So tension T in the string should be greater than or equal to nu mg upon cos 30 degree plus nu by 2. Let's put in the respective values. So nu is 0.4, mass is 100 kg, g is 9.8. So g is 9.8, cos 30 is root 3 by 2, nu is zero point 0.4, so this is 0.2. So t should be greater than equal to, so 0.4 into 100 is 40, and 40 into 9.8 root 3 is 1.732 divided by 2 into, so this is not into, this is actually plus. So this is plus, this is also plus. So with this 2, this is 0.866. So this is greater than or equal to 40 into 9.8 is 8 fours are 32, 9 fours are 36, and 3 is 39. So this is 0.866 plus 0.2, which is 1.066. Okay, so T is greater than or equal to 392 divided by 1.066. 392 divided by 1.066 is equal to 367.7. So this is 367.72. So that means the minimum value of tension should be 367.72 Newton. So T is equal to 367.72 Newton. This is the minimum tension that has to be in the string for the required for the given condition. So like, share, and subscribe. Thank you for watching.